Hello all, welcome back to my YouTube channel. So guys, this is video 6 of our machine learning playlist, and in this particular video we will be discussing about feature scaling. Feature scaling plays a very important role in your machine learning while creating your ML models, or before creating the models, also before transformation, like before encoding the models. This plays a very important role. So we'll be discussing about that in detail in this particular video. So before we dive further, I would request you all to kindly subscribe the channel and on the bell notification, and share this video with your friends who are preparing for data science role, or whoever are learning like machine learning or data science. So now let's not waste our time. Let's dive into the computer screen and discuss more about feature scaling. So guys, this is the article which is available with me to explain you all in detail. This article link will be in this video description. You can have a look on this, and even you can save it for further reading, and you don't need to write down or make a notes of anything whatever I am explaining. Everything will be available in this particular article. So in my previous video I have explained you all about feature transformation. If you have not watched that video, kindly check it out. If you don't see that, you will not get the understanding of feature scaling and why we will be using it. So guys, what is feature scaling? Feature scaling is a data pre-processing technique used in machine learning to transform the features of a data set onto a common scale, or else you can say into a common scale. It's nothing but like you have a wide range of data or a high sparsity data. There are many features, and like so many features are very far features also are there. For example, like if you take graph, for example a graph, okay, so you have features like a student studying is let's take an example of a student who is studying at his 10th class, 10th or something, grade 10th, and like he has 7 subjects. In that 4 subjects he got marks very close. Like let us take for 10 points, he got around like 4 5 4 5, like this, between 5 only for 6 or like another 3 subjects. What it happens, he got it very far, like 9 10 9 10. Now what it happens, like those are very far features when you compare. I'm just telling you all the example. I'm not telling you all that 9 is the highest rank or something, but I'm telling. So at this particular point, what happens when you use feature scaling, it will try to bring all them to the close, all those features very closely, and make it a kind of standardized. So I hope you might have not understood this properly. So to explain you all a bit properly, let me take a real time example. For suppose you have three friends preparing for you can say a running competition. So they are practicing every day, and when it comes to this running competition, there will be many factors like how much far he is running, and like how many kilometers he is running per day, and you will be seeing like what is his diet, control of food, whatever he is eating, and how much time he is spending in that particular practice, and also finally you will be seeing like how much calories he has burnt every day. So you will be calculating all this, and like everyone, like if you have 3 persons or 4 persons, you cannot expect everyone to have the same calories burnt, or else like same kilometers they are running or anything, because each person will be having their own fitness level, and each person will be having their own time and their like energy levels. So for this, what we will be doing, we will be calculating all this, and finally we will be standardizing it with the help of feature scaling, you can say, and we will be giving the overall result of each person. That's all. You will be not telling like he is good in this and he is bad in this. You will be not like showing the positive sentiments or negative sentiments. You will be finally just calculating everything, and finally you will be telling who is very good in, or like good or high chances of winning based on all these factors. That's all. So I hope you got this with this particular example. So you can see here, let's consider an example of a daily life. So here you have one more example related to currency notes. You can have a look on this. I am giving you all a unique example, and even this example is also a bit related in the article. You can have a look on this. This will also help you all to understand a bit more better. Now I'll give some points for why feature scaling is important. Let us discuss these points. Handling extreme values. So raw data might contain extreme values, like it's nothing but high sparsity or else highly different values. So like with when search data is used for model training without feature scaling, it failed to capture the essential patterns in the model. So if you have high sparsity, there is a chance that it failed to capture the essential patterns whatever it is required, and there is a chance that the model performance might be very low, and even there might be like overfitting or underfitting in this particular case. So fast conversions. So feature scaling enables gradient based optimization algorithm to convert in faster and most efficiently without using our raw data, which may like long converge time and make model train inefficient. So if you use raw data, there is a chance that it may take more long time, as I told you all, and there might be the training inefficiency. But when you perform feature scaling and use, the model performance will be very good, and even there is a chance for faster training or faster convergence. And when it comes to the third point, which is nothing but sensitive algorithms. So there are some sensitive algorithms in machine learning like SVM, support vector machines, and KNN, K nearest neighbor. We'll be discussing about this in our upcoming videos, and we'll be performing the practical, or else you can say like coding of, we'll be taking some data set and we'll be performing it. So don't worry, just understand these both are a kind of sensitive algorithm. So when you use this distance based algorithms, so what it happens like without any scaling, then the predictions will be inaccurate and also incorrect. So when you make feature scaling, then only these particular algorithms can perform predictions correctly considering its relative approaches or its neighbor approaches. So linear model and weights. Linear model uses weight factors, and when feature scaling is not applied, the weights may vary, which is nothing but one particular feature might have one weights and other might have very different weights because they are not near, they are not a neighbors. Like a neighbor, I kind of like we'll be saying right, one person and next to that another person. Like if it is like this, we can easily find out the features and we can easily find out the linearity. When they are not linear, then there is a chance that it might struggle to capture the data patterns, and model training also might be more, and inefficiency also, there is a chance of model inefficiency. Fair model comparison, like feature scaling allows for a fair comparison between different models. Training models on the same scale data simplifies the process and accessing the relative performance accuracy. So it's nothing but you can see with the name only it suggests fair model comparison. So if you train the model properly with the nearest features, then you have the better chances to compare with the upcoming good modules. Like for example, if you see in machine learning now, normally what it happens, if we have one data set, we'll be performing everything, but when it goes to the real time industry, you will be getting every day one or the other data sets, and again that will be enabled to the pipeline. Okay, so what it happens when you have that particular pipeline running, so if you perform feature scaling and standardization properly, and if you send that particular data, then it will train properly. Then what it happens, if it sees any improvement in the upcoming model, like you are now the model registered model is running, okay, so it's giving the good predictions, like it has some 60% of accuracy for example. So after this, whichever data it got, and with that when it has again retrained its model, then you can see there is some betterment in the accuracy. It's of 80%, or else you can say 70%. Then what it happens, it will fairly like shift from this particular model to next model. Fair model comparison is better because it will compare in between those models, and which model is having high accuracy and high like benefits, then it will switch to that particular model. It will register to that particular model, and predictions will be based on that model. Mitigating the cause of dimensionality. So dimensionality reduction, there will be high chances of dimension spaces. So for that, what we do, if we do feature scaling, then the chances will be very less. Impact on machine learning models. So handling non-linear data Many machine learning algorithms assume that the data is normally distributed. So normally this, if you take linear regression, even logistic regression, what these particular algorithms thinks that the data is linearly distributed. So if it assumes that, so when it's not linearly distributed, then there is a chances like uh, more imbalanced, and capturing the features it might struggle, and even there is a chance of dropping the accuracy. And even there are some more transformations also, like log transformation and boxcock transformation. These also I can take an example. Dealing with heterogeneous data, feature transformations are essential when working with data that contain a mixed numerical and categorical features, like encoding categorical variable and creating feature vectors of text space is an example of such transformation. Heterogeneous is nothing but like it has one particular column has both numerical and also categorical. Like for example, you can take loan ID. When it comes to loan ID of a person or an ID card of a person, like college ID or something, what it happens, you will be having like heterogeneous, right? Like you will be having 2 or 3 alphabets, like starting with the college or school name, and then you will be having the number. It's a kind of heterogeneous data. So to handle with that, we will be using feature scaling, which is very helpful to us. Robust to outliers. Some feature transformations like robust scaling and uh, winsorization can make model more robust to outliers of this particular data. This ensures the extreme values do not undelay influence of the model. So it's nothing but the particular data or else the features are like robust to its outliers. So it's very near to the outliers, then there is a chances of getting more overfitting. Better handling of date time data. So when it comes to date time data, it can handle betterly when we perform feature scaling. Model can handle. Specifying complex relationship. Feature transformation can specify complex relationship within the data. For example, model can capture non-linear patterns more efficiently by transforming continuous variables into categorical data or categorical bins. So this is another example, like complex relationship can be simplified. So types of feature scaling. The aim of feature scaling is to bring the data into a common scale, which is nothing but between -1 to 1 or between 0 to 1. So it will just bring to that particular one line, you can say. So it is mainly divided into two types. One is standardization and one more is normalization. So for this video, the overview of feature scaling is over. In your next video, we'll be seeing about standardization, where we will be taking a data set and we'll be practically implementing also. So guys, that's all for today's video. Do like, share and subscribe the channel. And also if you have any doubts, you can directly reach out to us by clicking on this email if you are seeing the article, or even you can comment below this video. So that's all guys, bye bye, meet you all in the next video.